Welcome to the Ecosystem Intelligence, or EI, platform. EI is a decision support platform designed to help users understand the impacts of their decisions upon the environment. It's relevant anywhere on the globe and has been used on every continent except Antarctica. It can be applied at any scale, from your backyard to entire landscapes and service sheds. It applies to the natural environment and the built environment and is designed to help us understand the linkages between the two. EI enables users to quantify ecosystem performance and to model the likely effect of alternative land management and project design scenarios, and to monitor performance over time for adaptive management purposes, for ESG reporting, for financial disclosures, just trying to improve performance and seek a more nature-positive outcome. EI is built around the ecosystem services cascade that you see here in the middle. Intuitively, we all know that the condition of the landscape dictates how that landscape performs. For example, we know that the ground we're standing on is covered with asphalt, which is an attribute. That asphalt is going to intercept water from a rainstorm, and that rainwater will be prevented from infiltrating into the ground. Rather, it will likely either evaporate or run off, or a mix of the two. Similarly, if we're standing in a forest, it makes logical sense that rainwater that falls on the forest canopy will be intercepted. Some of it will evaporate, some will flow down through the canopy and hit the understory, and some will reach the forest floor, where it can then be held in the leaf litter and duff, and it can infiltrate into the soil and contribute to groundwater recharge, resulting in very little, if any, runoff. This highlights an example of relationships between landscape attributes and key ecological functions or processes, but we can take that a step further in the ecosystem services cascade. The way in which different ecological functions contribute to ecosystem service production is also known. Using the same stormwater example, the relationships between those key ecological functions, such as interception, evaporation, infiltration, and groundwater recharge, are known and can be expressed in terms of ecosystem service benefit production, in this case, stormwater management or water quantity control. The second tier of modeling outputs produced by the EI platform helps us understand not only the impacts of our decisions on the environment, but how those impacts ultimately affect the people who rely on the environment for survival and quality of life. The platform's models capture these relationships and offer 52 different metrics to help us understand how our decisions affect ecological performance and ecosystem service benefit production. This enables practitioners to also begin to understand the concept of ecosystem service benefit flows and service sheds. Ecosystem services are spatial, after all, meaning they are produced in a certain place and their benefits can be experienced very locally, such as in the case of stormwater management, or globally, such as in the case of carbon sequestration. Understanding benefit flows helps us understand who is affected by the decisions altering the landscapes and provides quantified information to support conversations about benefit value and beneficiary impact. Whether value is determined by stakeholder priorities, monetary asset accounts, or cost-benefit analyses, EI provides outputs to support the value conversations, but valuation is not a component of the EI system itself. The relationships between individual landscape attributes and ecological processes and ecosystem services are known. It's not rocket science, but systems are complex. Our platform is unique because we've spent the last 20 plus years working with over 100 subject matter experts to capture those relationships in Bayesian belief networks so that we can understand the push and pull between decisions that affect landscape attributes and ultimately the way the ecosystem functions. It helps us understand the social and economic impacts of landscape change. The EI platform has numerous features and resources. At the highest level, we offer an ecosystem integrity portfolio dashboard to track performance at a site level or across an entire portfolio using our ecosystem integrity score. It provides a one-number roll-up that compares performance to a system-provided reference benchmark. In 2025, we'll be adding a new front-end risk assessment or context module to help users understand the landscape context in which a given site is located in terms of key ecological needs and community drivers. Already in the system and available for users are the screening and design modules. The screening module can be thought of as an estimator that helps users very quickly understand likely performance compared to a reference benchmark using typical data that are pre-populated in the system. The design module is a detailed and robust analysis tool that enables the user to use site-collected data to model and quantify current conditions as well as infinite scenarios and to monitor a site through time. I'll briefly walk you through each of these resources, but first it's important to note that these tools are relevant anywhere and at any scale. I won't subject you to endless examples of various applications, but I will share quite a few with you. We encourage you to reach out if you have questions about your particular use case or application. Although there are 52 metrics in the system, the dashboard focuses on just 13, which are rolled up into the 7 key categories that you see here. We've chosen these categories based on our experience with what users desire to report out on in the elevator speech context. So this is the highest level of output rolled up for summary explanatory purposes. The dashboard emphasizes performance in terms of our ecosystem integrity score. The score reflects how well a site performs compared to a contextually appropriate, highly functioning reference site. We at Ecometric Solutions Group have chosen to think of highly functioning reference condition as our definition of nature positive. We aim to help users understand the gap between the function of their site and the highly functioning reference benchmark our system provides to help inspire users to improve land management and design decisions to help narrow that performance gap. The Ecosystem Integrity Score also encourages mimicking performance to align with performance across each of the 7 categories, not optimizing for one at the expense of others. It helps users spot the potential for unintended consequences. The platform contains reference benchmarks for every realm and biome. It captures the differences between different geographies and provides benchmarks and targets that are context appropriate. Obviously, we would not want to encourage land managers to strive for the performance values in a desert that match performance values in a temperate forest. It's simply not sustainable or ecologically appropriate. Our benchmarks are tuned to place and are provided to help users understand how their site performs in context with their local environment. Users are also free to set their own benchmarks in other parts of the system. This figure provides an example of how the Ecosystem Integrity Score can help us understand the consequences of our decisions. Scenario 1 on the left shows a site's baseline or current performance in blue compared to reference in gray. That's a pretty big gap, and in scenario number 1, the project proponent proposed some relatively minor improvements to help fill the gap, which you see in green. In scenario 2, they got a bit more ambitious and drastically improved performance for several categories, but because this particular project focused on planting a monoculture of non-native spruce to optimize for carbon, it did so at the expense of biodiversity and soil. So here you can see that a carbon overshoot at the expense of biodiversity and soil scores lower than the third scenario, which kept everything aligned with the balance suggested by the reference condition. The dashboard provides an alternative view in addition to the previous radar chart. You can also see the total number of service acres or hectares produced by a given scenario as stacked benefits. Again, those same 7 core categories are stacked vertically, so we can see the overall amount of benefit provided. The EI score can be viewed as a portfolio-wide roll-up or on a per-project basis. I'll show you a couple of examples. Let's take a look at what happens if we add design interventions to a business-as-usual data center design. We're able to see that adding native vegetation, green roofs, and additional pervious surfaces and nature-based solutions, we're able to increase our performance from 10 to 72 on a scale of 1 to 100, with 100 reflecting the reference benchmark condition. Similarly, we can do the same thing for infrastructure projects and begin to understand the potential cumulative benefit of many nature-positive projects on the landscape. The approach is relevant to any type of infrastructure project or landscape restoration project. It really doesn't matter. If you're changing land management or land cover types, the impact, whether it's positive or negative, can be quantified. The impacts can be rolled up, importantly, across an entire portfolio of projects. It can be a combination of infrastructure projects, of restoration projects, or a mix of the two. It really doesn't matter. You're able to see what your baseline performance was, in this case, across these different projects at 21, and what our cumulative benefit is when we look at them as a portfolio, in this case, 66. And we're able to see how our different actions are aligning with the desired reference condition. Now we'll drill down into the tools that provide the outputs that are used to calculate the ecosystem integrity score that I just showed you. I'll start with a built environment example and then provide some other examples from different contexts. But again, remember, everything that you're about to see applies in the built environment the same as it applies in the natural landscape. We'll start with the screening or estimator tool. Screening is a high-level tool that requires no original data beyond your site location and the identification and delineation of the land cover types that are present. When you identify your property boundary, the system automatically identifies for you your realm and biome so that it can offer you the reference benchmark performance target automatically. All you have to do is carve your site up into the land cover types that are present, pick the corresponding land cover type from a drop-down list, and you instantly have your initial performance assessment. Here we can see our site compares to reference in its starting condition. But the real power of the screening tool is its ability to support what-if scenarios that require virtually no effort to explore. You can play around with adding and subtracting different land cover types and see how doing so either increases the gap or helps to narrow it. Here I've chosen to remove some standard roof and paved surface and have added green roofs and native plantings. I can begin to see progress, and I can continue to experiment and play what-if scenarios to improve my site. The power of the red box in this example is that it provides approximate quantities of things that I might need to factor into my design budget to improve performance. This is key because we all know that if sustainability measures are not accounted for in the earliest budgeting setting conversations, they ultimately get value engineered out on the backside. So the screening module lets you quickly, in under an hour, estimate performance values for your site and high-level design scenario concepts. Now I'll introduce you to the design module, which relies on site data provided by the user rather than canned or typical data and drop-down values provided in the screening tool to quantify performance for baseline, endless scenarios, including monitoring as-built conditions and monitoring events through time. The interface looks similar to the screening tool, only here you can see that the user is asked to answer very specific questions about site attributes for each survey unit they create on the site. Like the screening tool, the user can model a suite of alternatives. In this example, we compare the baseline parking lot to what was actually constructed and explore what could have materialized if additional interventions had been feasible. The initial outputs are similar to what we see in the screening tool and are focused on the 7 primary benefit categories. And here we've created a custom target unique to this particular site, but the reference biome target is also available in the design module. But in the design tool, we can drill down to a deeper level of detail, and information is provided in heat ramp format to help identify the push and pull between the various metrics under each scenario. Everything in the platform is presented in a common unit of measure, be percent performance or a functional acre or functional hectare, or a service acre or service hectare, to help highlight that push and pull and identify unintended consequences between measures that are typically siloed and hard to compare. For example, air quality versus habitat suitability for a particular species group. That's hard to do unless you use a functional assessment unit of measure, as we've done in the EI platform. As you drill down into the tool's 52 different metrics, you're able to zero in on the platform's biodiversity measures. EI's biodiversity measures are a robust reflection of habitat suitability. For each scenario, you're able to see how each life history stage requirement, so for example, nesting, breeding, cover, refugia, forage, are met for each species group. So insects and invertebrates, amphibians and turtles, songbirds, raptors, bats, small mammals, large mammals, etc., and a number of key vegetation metrics. All of that ultimately rolls up into our overall biodiversity number. Because it's habitat suitability based, it helps you understand the ability of a site to support various species groups based on how site management and design decisions affect site suitability. And you can monitor over time, and you can pair this tool with other tools that document species occurrence data through mapping or eDNA. The system also provides engineering units for those who choose to use them for cost-benefit calculations or avoided cost replacement cost calculations. However, we encourage users to focus on the integrated and holistic common unit of measure provided by our functional and service acres or hectares to ensure a systems level understanding of performance and change. The design tool also provides heat mapping functionality for each function and service. These maps show the location and relative strength of benefit production. Because everything is in the same unit of measure, we're able to understand how the roof in the middle example performs poorly for air quality, but performs relatively well for reptiles who like to loaf on the warm, dry surface that it provides. The design tool can also be paired with a field data collection app available in iOS and Android to support field data collection efforts. Desktop data entry is also possible, and it's particularly useful for modeling future design scenarios based on master plan concept, planting plans, and restoration plans. The field app is also very useful for monitoring updates that capture as-built conditions and the evolution of a given site over time. Now I'll walk you through a couple of example applications. We'll start with resilient agriculture. In this example, we've modeled the anticipated benefit production from a traditional business as usual industrial agricultural practice and compared that to resilient agriculture in a net positive context. Here we're able to see for those stacked benefit categories how performance changes between the two different scenarios compared to our reference benchmark condition. We're also able to take a look at this from the ecosystem integrity score, which we see here, which shows us going from a 26 on the left to a 70 on the right in comparison to the highly functioning condition of 100 in our reference ecosystem. Now we'll take a look at some examples from a renewable energy portfolio. Here we'll take a look at a couple of solar farm examples and a wind farm example and understand how performance at an individual site rolls up into a portfolio level assessment. We can drill down into the performance values for each site from its ecosystem integrity score and see how they contribute to that overall roll-up that we looked at a moment ago. And then we can drill down into the data behind the ecosystem integrity one number roll-up scar to see how each different category performs for both the baseline condition and the reference condition. In this example, we also tease out the lime green area, which is our biodiversity metric, so that we can see over on the right the habitat suitability for each of the species groups that are modeled for the project location in both the baseline and biome reference condition. We are also able to take a look at what happens under different land management scenarios. In this example, we've taken a portion of one of the sites and converted it from traditional agriculture to resilient agriculture in conjunction with the existing wind farm practices. In this case, we're able to see our performance values increase from 40 in our baseline condition to 55 in the improved condition. And as before, we're able to take a look at this information broken out in terms of the stacked benefits that are provided for the 7 categories of metrics. And again, on the right, tease out the information that we're interested in from a biodiversity perspective. Another example of heat mapping, this is the biodiversity roll-up for all the different species groups in terms of habitat suitability in the initial scenario, which is the traditional agriculture and wind, compared to the traditional agriculture and a portion of the site being converted to resilient agriculture in conjunction with wind. And as a final example, we can take a look at habitat suitability for songbirds. And again, this type of heat mapping is available for all of the 52 biotic and abiotic functions and services that are available in the Ecosystem Intelligence platform. Thank you for taking the time today to learn a bit about the Ecosystem Intelligence platform. I hope this tour of the EI platform has been informative. Our mission is to enable pervasive positive impact on the landscape. We enable system users to think outside of traditional regulatory silos and to adopt a systems-based approach to understanding the consequences of land use change. If you have questions about the enormous variety of applications across the globe, regardless of location or scale, please reach out and we'll be happy to help you explore your potential use case. Please note that there are many resources available to help you on your journey through the Resources tab on the Ecosystem Intelligence website. Thank you.